Hi, my name is Ronnie Cordova. I'm a senior software engineer, full-stack web developer with more than 7 years of experience in the industry. I've worked designing and implementing a variety of software solutions, starting from common applications like CRMs and ERPs, all the way up to custom libraries and frameworks. And today I'm going to show you how to code the Fibonacci sequence. So this is an overview of what we will be learning today. First, we're going to be understanding the problem, and that's always the first step we should follow as software engineers. We need to make sure we understand whatever problem we are asked to solve, right? So in our case, we will be learning what is the Fibonacci sequence exactly and how can we translate it into a programming language. After that, we will be implementing the solution, and by that I mean that we will be defining the scope of our application, which means that we will have a clear idea of what exactly our application will be capable of doing, right? And after that, we will be coding, right? First, we will have a basic implementation of the Fibonacci sequence algorithm, and after that, we will add some code to check for some edge cases that may occur in our application, right? So let's start. What is the Fibonacci sequence, right? So the Fibonacci sequence is an infinite sequence in which each number is the sum of the two preceding ones, right? So it's pretty straightforward. Let's take this number 8, for example, right? The two preceding numbers to this number 8 are 3 and 5, right? So 3 plus 5 equal 8, right? Same thing, for example, with number 21, the two preceding numbers 8 and 13, 8 plus 13 equals 21, and so on, right? So that's basically it. Now the question is, okay, what is the pattern here? How do we implement this into code? So let's start by checking the definition, and the first thing that I would like to highlight is this section here, two preceding ones. So each number is the sum of the two preceding ones, right? So that means that in order for us to be able to calculate the first term in the Fibonacci sequence, we need to have two preceding ones, right? So the only way for us to have two preceding ones is if we define them beforehand, right? So the first item or term that we can actually calculate in the sequence is this number 1 here, right? Because it's the first number that has two preceding numbers, right? So that will be calculated in our first iteration. So let's see it here. This is our iteration number 1, right? So we will want to calculate this number 1 here. I'm calling it next term, which is the name that we will use in our programming language. And then the two preceding numbers are term 1, 0, and term 2, 1, right? So in my next iteration, after I calculated this, then I want to calculate number 2, right? And then the values for the term 1 and term 2 should be updated, right? Because now my term 2, my first preceding number is this one here, and my term 2 is this one here, right? So in my next iteration, right, now, same thing. Now I want to calculate this number 3, right? So my term 1, now it's the number 1, which is this one here, and my term 2 is the number 2, which is the 2 here, right? So let's see something here, right? On each iteration, we can identify the pattern, right? So if we see an iteration number 2, my term 1 equals my term 2 on iteration 1, right? And my term 2 equals the next term on my iteration 1, or the value that I was calculating on my iteration 1, right? And the same thing repeats on iteration 3. So now my term 1 equals my term 2, right, on my previous iteration, and the term 2 equals the next term of the previous iteration. So this is the pattern, and this is what we need to identify as software developers in order to write the code that implements this particular sequence. So hopefully you understand this, because now we can continue by implementing the solution, right? Now that we have a clear idea of what the Fibonacci sequence is, we need to have a clear idea of what is the scope of our application. And usually in the real world, in order to do that, we will have the user will give us the requirement, right? Whatever they need our application to do. So for this example, we will assume that the requirement is that the user wants to calculate the sequence up to a number n, right? So that means that we'll have a function, and let's remember that a function is just a piece of code, right, which executes a specific task. So in this case, it will generate the Fibonacci sequence, right? It will receive an input, which is the number n, and it will return the n terms of the sequence, right? So if the user inputs 8 here, we should be returning the first 8 terms of the sequence, right? So, okay, now we have a clear idea of what our application will do. We will have this function, so we just need to implement it. So let's start coding. Let's start with our basic implementation. So as we discussed, this is JavaScript, and I have here my function called generate Fibonacci, right? Which will generate the Fibonacci sequence up to a number n, right? And I have here the definition of the Fibonacci sequence, which is that each number equals the sum of the two preceding numbers. So as we discussed, we know that the first thing we need to have is the first two preceding numbers, right? So this will be term 1 and term 2, right? And we know that we need to return the sequence to the user. So for that, I will add an array, right? I will call it Fibonacci sequence, right? And it will be initialized with term 1 and term 2. And then at the end of my function, I will be returning this Fibonacci sequence to the user. So, okay, now we just need to implement the logic, the pattern that we just described, right? So we need to do that inside a loop, right? Because we need to calculate, generate the Fibonacci sequence up to the number n. So if the user inputs here 100, we need to generate 100 terms. So for that, a for loop is the way to go, right? So we will initiate our loop at the index 2, and I will explain why is that in a second. Then our index should go all the way up to the n number, and we will increment our index by 1 on each iteration, right? And why am I starting at the index number 2? It's pretty straightforward, right? It's because we already have two defined numbers of the sequence, right? So if the user inputs here the number 10, since we already have two, we only need to calculate or generate the remaining 8 terms of the sequence, right? So in order for us to achieve that, our loop should run 8 times in this particular example. So that's why I'm starting at index number 2. So, okay, now inside here, we just need to calculate what is the next term. And we know that next term equals term 1, right, plus term 2, right? And then I will just add what we just calculated to my Fibonacci sequence array, right? And that's it. The only thing that's remaining for us is to implement the logic, the pattern that we just described before, right? Where we know that term 1 equals term 2 on the next iteration, and term 2 equals the next term, right? And that's it. Now we have the basic implementation. If we go ahead and call this function, right? Generate Fibonacci, and let's give it the number 10. And I will run this. We see that we are getting the first 10 terms of the sequence correctly, right? So, cool. We have our basic implementation in place. Now, what we can go ahead is write the code for the edge cases. And what exactly is an edge case? So, an edge case is, let's call it as unexpected ways that the user may interact with our softwares. Like, for example, let's say instead of 10 here, for some reason they input -10, right? Which doesn't really make sense. Why would they ask for -10 terms of the sequence, right? But they could do it. Users are capable of using our software in really unexpected ways. Believe me when I tell you that. So if I run this particular file, we see that we are getting a weird result, right? We are getting the two first terms of the sequence. So this doesn't really make sense. Our application shouldn't be behaving like that. So our code should control, should check, or should validate for these particular edge cases. So in this case, I will just check if n is less or equal than 0. Sorry for that, right? In that case, then we want to return an error, right? Because we cannot return anything else. So it will be an invalid input error, right? So that way, if I go ahead and run this, now we're getting invalid input error. So the user would see that and say, oh, okay. So I need to input a valid number, right? So there's one more edge case, and hopefully you already know it by now, that we need to check. And that's what happens if the user inputs the number 1, which is not a negative number and it's allowed. But if they go ahead and do that, so for example, let's make here this number 1, right? And let's run this again. Okay, we are getting the first 2 terms. And that's because we initialize our array with the first 2 terms by default, because that's what we need to do, right? We need that to calculate the Fibonacci sequence. So we need to control that, because that's also an edge case. So in that case, if they ask for 1, we will just return 0. And that's it. We now have accounted for that particular edge case, as you can see here. So that's basically it. If I go ahead here and let's have some test cases, right? We will see here with the first one, we're getting the first item, then invalid input error, and then the 10 and the first 5 terms of the sequence. So now we have an implementation of the Fibonacci sequence algorithm, which is not only functional but also reliable. So thank you very much for your attention. I hope you learned something new today, and I'll see you at the next one.